Welcome to a lesson with Dr. Powell. Let's look at an adjacency matrix in another way, with the rows. First, what does this mean? This means maps into V1 from V1. This means maps into V3 from V1. Wait a minute, everything here is from V1, everything here is from V2, everything here is from V3. As if we're going out of V1 to things, out of V2 to things, out of V3 to things, instead of coming into, like we think of for columns. So this answers the question of coming out of instead of coming into, analogous to what we have for columns for an adjacency matrix. Likewise, we have a module map from Z4 to Z4, and we can represent input to output via a matrix multiplication, where the input is a row and the output is a row, but it happens by putting the row on the left. So this row would represent V1. And what comes out of V1 when we matrix multiply? Well, the image of V1 is simply the first row. So we think of the rows as being the images of the standard basis elements, V1, V2, and V3. So if we matrix multiply to A, we end up just getting 1, 0, 1. What if we took the collection of all the vertices with multiplicity just 1 for each position, 1, 1, 1. So this means what comes out of all the vertices into 1, all right? So coming out from everything, what comes to 1? From here all the way to 1. Well, notice the arrow tips. Aha, arrow tip here and here, there's 2 at V1. We should get 2. What about to V2? Well, there's 2. Well, from the collection of everything coming to V2, there's 2, because there's 2 arrow tips at V2. And there's 2 arrow tips at V3, so we should imagine this being 2, 2, 2. Is this accurate? Well, this just means take first row plus second row plus third row. And if you check it, 2, 2, 2, yes, it works. Okay, what if we were to do like a multi-set of things, like 2, 1, 0? Okay, so this means that we're going to double count what happens as we go out of V1. So think of the arrows. This arrow will count as like 2 arrows. So why don't we just draw another arrow right here? And this arrow right here will count as 2 arrows. Okay, so what would we get? Well, we just think of, okay, so what comes out of the collection right here, V1 and V2, with the corrected arrows for the multiplicity drawn, what coming out of V1, double counted. Okay, so we have coming out. Okay, so coming out of this collection, coming into V1. So we think, okay, so for the output, we think of things coming into. And notice when we had columns, we were thinking for the output where it came from. So we were thinking of, things coming out of. But now for the output, we're thinking of things, of destinations now. So destination V1, how many things? So think of the destination V1 coming from this collection of V1 and V2. Notice that there is, one arrow coming from here to V1. And let's see, also coming to V1. So you have this arrow and you have that arrow. There should be three arrows coming to V1 and coming out of the collection we have right here from V1 and V2. Okay, now coming out of this collection to V2. Let's see. Looks like 0. Nothing, I think. Yes, because arrows come into it, but not from the collection that we are considering. So that would be a 0. Okay. And then we have, okay, what about things that come to V3? Well, let's look. from our collection. Well, nothing from V2, but from V1, oh, there's 2 paths with the correction there for multiplicity. So there should be 2. Okay, and let's check to see if that's accurate. So let's take 2 times the first row. That's 202 plus 100. That should, yes, that should work. That should be 302, just as expected. Thanks for watching.